Hi, we're going to look at how to solve a system of three equations. So we have three equations, three variables. Everything's lined up. X is Y, Z is good. Now, the whole goal here is I need to pick a pair of equations, two of them, and I need to start eliminating something. Well, before we do anything, let's label these. I want to label 1, 2, 3. This way we know what we're talking about. And now we need to start piecing things together. So if I take a look at the first two equations, um, just with elimination, will anything cancel out? Well, if I look at my x's, I've got +2 and a -2. Again, we want the same number. We want a positive, we want a negative. Yeah, that's going to cancel out. So our first step is let's rewrite equations 1 and 2 and create a new equation, equation 4. Okay, so we take 1, 2, let's add them together. 2x minus 2x cancels. We are left with 1y, 4, -4 plus 1, -3z equals 19. Great. New equation, just y and z. Let's leave it. We're going to call this something new. We're going to call it 4. Let's come back. So we already talked about equations 1 and 2. I now need to talk about equation 3. 3 has to get paired with one of the other two. So it's going to be 3 and another one. Now, we eliminated x in this first pairing. I also need to eliminate this x. I need to now figure out which x would be easiest to eliminate, a -2 and a -2, or this -2 and a +2. I'm going to go with the negative and the positive. So this time, I want to look at equation 1 and 3. You're always going to repeat something. And in this case, we're repeating equation 1. Rewrite everything. And we're going to eliminate. 2 minus 2, goodbye. -4 and 3 gives us -1y. -4 and -2, -6z equals, where are we at, 26. New equation, y and z, just like the previous one, we're going to call this 5. Now, I want to then take equations 4, equations 5. They're the ones that both have two variables in there. And we're going to do the same process all over again. So we're going to say 4 and 5. 1y minus 3z, 19, -1y minus 6z, and 26. And we're going to try and eliminate here again. Lucky for us, we have a +1 and a -1y. Those disappear. We get -9z and 45. We have one variable, solve for that one variable. We're going to divide, use that inverse of multiplication. Z equals -5. Congratulations, we have one answer. We then need to work our way backward, back to the beginning in order to figure out all of our variables. So let's kind of start by taking a step. I want to take this. I want to plug it into either 4 or 5. It doesn't matter. So I'm going to take it and let's plug it into the top one, I guess. So 1y minus 3 and a -5 equals 19. Y plus, subtract that 15, y equals 4. Good. We now have a y, we now have a z. I want to take both of these and go back to the original. I want to now plug it into either 1, 2, or 3. Doesn't really matter. I'm just going to take equation 1 just because it's up top. So we're looking for x, so we're going to say 2x minus 4. My y was 4. My z was -5. And now let's just simplify and try and get the x alone. Inverse operations all around. X equals 2. Now, how do we write our final answer? Our final answer has to be written as a coordinate. It's a coordinate in 3 dimensions. So we need, instead of x comma y, it's going to be x comma y comma z. So our final answer, 2 comma 4 comma -5. And that is solving a system of 3 equations with 3 variables.